Hi everyone. So recently I asked a question on YouTube and on Twitter, and I wanted to find out whether this object with these three arms and it looks like six rotational kind of elbows has multiple representations in the quaternion space. Let me slow down for a second here. Let me explain this. So quaternions are basically these coordinates, or these four-dimensional complex numbers, I guess. But the nice thing about them is that they represent rotations really well. So these could be rotations, for example, of a camera in a video game. And Half-Life was a video game that used quaternions to move the camera around, and it always moved very smoothly because you don't have any sort of weird rotations with gimbal lock. You just have smooth matrix transformations, movements, basically around a sphere, if you wanted to think of it as a sphere. But the quaternion coordinates also represent the tilt of the camera as well. So it doesn't matter which way you're facing. You could be facing up, down, sideways. You could be tilted any way that you can imagine. And no matter what other way you want to be facing, and no matter what other tilt you want to be facing, it is completely smooth. It is completely symmetrical in the mechanics. There's no up or down that's treated differently. Like, there's no gimbal lock problem. There's just always a smooth transition from one rotation to another. So I realized this should also be the representation for how they compute rocket coordinates or rocket rotations, because then you don't have to worry about your gimbal controls being all out of whack just because your rocket is kind of turned in a weird way, vertically or something. So I wanted to find out, does this device that has like these three arms and that rotates this little platform around, does this device, how should I phrase this? When you represent the coordinates of, say a camera point, and imagine a camera being mounted to this device pointed out. When you rotate, or say a rocket thruster, it doesn't matter whether it's a camera or a rocket thruster, but when you represent the coordinates of this rotation, not the position, right? The rotation, and that, by the way, that includes the tilt, but tilt probably doesn't really matter for a rocket engine because you're literally just, you're rotating the engine itself. That might matter if one side of the engine is, propulsing a little more, but that's more advanced. But the question is, if you only move things on this device, on this platform, there's something that happens with quaternions where there's actually two representations. So if I can freely move, like say in a spaceship or a camera, as I'm moving with quaternions, there's not one, but there's actually two different sets of quaternions that represent that same exact angle that I'm looking at in the tilt. There's actually two different sets of numbers, two sets of four complex numbers that represent that same exact tilt, that same exact rotation. But I can reach both of them based on how I turned and tilted to get to that coordinates, right? So my question is, if you're just using that one device, okay, is all the coordinates that you can reach when you account for the rotation and the tilt, are all the quaternion coordinates that you can reach only going to be represented by one? Or is it possible to rotate it and move it around in such a way that you can reach the same angle, the same position, the device would be in the same position, but it's actually represented by different quaternions? And another question to go along with that, I suppose, could be whether or not the legs of devices, and this is a general question, but you can actually have different positions for the legs of a device such that the camera that it's mounting is the same for two different ways that the legs can be represented. So, whether or not you're doing video game cameras or you're controlling rockets, my curiosity is to find out just how do we do the math for this?